Welcome to this technical guide on reliable overcurrent protection by design, focusing on the Murata PRG series. We will explore how these resettable, ceramic-based PTC thermistors empower your designs with superior stability and safety. Advanced circuits require resettable and maintenance-free protection. The PRG series acts as a resettable fuse, automatically returning to its initial state once a fault is cleared. These ceramic-based devices offer high reliability, fast operation, and a compact design. The PRG series reliability comes from its unique ceramic material. Protection is based on the electronic properties of ceramic grain boundaries. When an overcurrent event causes the PTC to achieve its trip state, the resistance dramatically increases, protecting the circuit before resetting to the normal state. Ceramic PTCs offer unmatched stability after soldering and load cycling. Their non-hysteresis characteristic ensures stable performance, with virtually no change in resistance, even after reflow soldering or thousands of on-off power cycles, as shown in the data. Selecting the correct PRG thermistor is a simple, three-step process. First, determine the maximum voltage applied. Second, check the current flow under normal conditions. Finally, check the current flow under abnormal conditions. Steps 1 and 2 involve matching voltage and normal operating current. You must ensure the line voltage is less than or equal to the PTC's maximum voltage. Then, ensure the normal current is less than or equal to the PTC's hold current at your operating temperature. Step 3 is verifying the trip current. The PTC's trip current must be less than or equal to the circuit's abnormal current to ensure guaranteed operation. For our example, a suitable part number is PRG21BC2R2MM1RK. Understanding the protective threshold involves two key ratings. Hold current, or I-hold, is the maximum current guaranteed not to trip. Trip current, or I-trip, is the minimum current guaranteed to trip. Your design should operate outside the shaded protective threshold current range. A design pro tip: ambient temperature is the actual surface temperature of the PTC device before it's powered on. In reality, nearby heat-generating components can significantly affect the operating temperature of the PTC, which influences its performance. If your normal operating current exceeds a single device's hold current, you can use two PTCs in parallel to double the capacity. A crucial consideration is that the PTCs must be located separately on the board to avoid mutual heating, which reduces the combined trip point. To fine-tune protection, understand the time-to-trip characteristics. The time it takes to trip depends on the overcurrent magnitude, the PTC's resistance, and the ambient temperature. Lower resistance parts and higher ambient temperatures result in faster tripping. The PRG series offers reliable protection for demanding applications. Key advantages include superior ceramic technology, resettable and maintenance-free operation, compact size, and safety standard certification. Applications include automotive, factory automation, and various consumer electronics.